All right, we're going to move along to our next presentation, which is end-to-end charging solutions for electric vehicles. And I've got Vim on the line. Vim is the Group E-Mobility Solutions Area Manager for Latin America, Africa, Middle East, and Asia Pacific at ABB. Vim, that is a very big portfolio.
Yeah, thank you very much. But unfortunately, due to the current situation with COVID, I'm stuck in the past. I used to call this my man cave, but it's become a man cage right now. So I'm caged, not allowed to travel to all these beautiful areas in the world that you just mentioned.
Are you stuck in Netherlands? Is that where you are stuck?
Yeah, I'm stuck in the Netherlands. That's where our headquarters is based. We started as a startup company from a university to develop DC fast chargers for electric vehicles. And we got acquired by the Swedish company ABB around 10, 12 years ago. But headquarters of the company, although we do belong to ABB, being a Swedish company, headquarters is still based in the Netherlands. So yes, I'm stuck in my cage in the Netherlands.
Sounds like a great cage to be stuck in at the moment, Vim. I'm not going to keep you for much longer. You are going to be chatting to us about end-to-end charging solutions for electric vehicles. So take it away.
Yeah, thank you very much, and thanks for the introduction. And it's great to be on stage today, on the virtual stage today. And I'll be introducing you today to the end-to-end e-mobility solutions that ABB is offering to the market. For those of you who do not know ABB as the DC fast charging supplier, we are the global market leader in fast charging solutions for electric vehicles, whether that is cars or buses or trucks or other industrial equipment. And we supply our chargers to more than 82 countries in the world, where we have installed more than 17,000 fast chargers at the moment. Unfortunately, you see that the installed base in Africa is still limited. We have a few chargers installed in South Africa, and there's a small red dot in Central Africa where we have installed a few chargers in Rwanda, and in Northern Africa we have installed a few in Egypt and in Morocco. But this market is emerging, so we are preparing ourselves to support Africa as well to further electrify mobility, and that's why I'm in this call today as well to show you on how that can be done and how we can support with that. The customers that we serve, it's a mix of customers. First of all, we work close together with the car OEMs, and by working with these car OEMs, these Chinese, Japanese, Korean, American, European car manufacturers, we've learned a lot on how these cars have to be charged. And in fact, with these car OEMs, we have defined the standards that are being used today to charge electric vehicles. We also work a lot together with the utility companies, who of course recognize that every outlet, every charger on the street is an extra outlet for them. So that actually is a business boost for the utility companies. And another key segment that we work with is the oil and gas industry, or the petrol stations, maybe I should call it like that. So three key segments for us: car OEMs, utilities, and petrol companies that we work with. And if you look at the global map, where the major customers are, we work together with the major charge point operators in Europe, in the US, where EVgo and Electrify America are big players, in Latin America as well, which is a fast evolving, emerging market, and in Southeast Asia, we work with the major charge point operators as well. The short introduction on ABB, on our role in e-mobility, but that's not what I'm here for to talk about for the whole afternoon. First of all, let's start with these two fellas, these two gentlemen, and I don't know if you recognize them or not, but if you do, you do recognize Thomas Edison, a pioneer in the electrical segment, and you do recognize Henry Ford, Um, what's interesting for you to know is that Thomas Edison used to work for Henry Ford, and in the early days, back in the 1900s, Thomas Edison already developed an electric car for the Ford company. It was called the Ford E. So you have to imagine that those days the electrical segment and the automotive segment were really coming together. Unfortunately, already in those days, that initiative was killed, and it failed to be successful. And there's still the big rumor that already those days, back in the 1900s, it was the petroleum lobby or the oil and gas lobby that actually killed this initiative. So I'm also happy to say then, and that I'm very happy to see that an iconic car like the Ford Mustang is now being electrified and is actually going to be one of the major cars that Ford will bring to the market. So far a contribution to these two gentlemen, but it's actually also touching on the topic that I wanted to use as an introduction for my presentation this afternoon, to show you how the electrical and how the automotive industry are coming together these days. And I saw this coming by in other presentations earlier today already. If we look at the disruptive trends that we currently see in the automotive market, in the mobility market, which is called the ACEs. And if we quickly go through them once more, then we see these disruptive trends that keep the automotive CEOs awake those days. First of all, cars are becoming more and more autonomous. If we look at the anticipated business growth in autonomous vehicles over the coming decade, that is tremendous. And it is predicted that around 40 to 50% of the revenues in the automotive industry might be coming from autonomous vehicles in the decades to come. Oh, sorry, in the next 10 to 20 years to come. Then, hand in hand with going autonomous is the electrification of mobility. We've seen this trend now over the last 10 years, and that's how I started my introduction as well. As a startup company, we started 12 years ago. ABB acquired us 10 years ago when the first cars were being electrified. These were then cars that didn't meet any standard for charging. They just had a battery inside, and they had to be connected to a AC/DC converter without any standard for the socket in the vehicle or the connector to the charger. And that then evolved with the Nissan Leaf coming to the market, and Volkswagen and BMW bringing electric vehicles to the market into the standards that still exist today. The CCS standard for the European American cars, and the CHAdeMO standard for the Japanese vehicles. So cars becoming autonomous, cars being electrified is one thing, but the other thing we see is that cars are all connected these days and are being shared. So if we look at the impact that the taxi industry is currently having, and the car sharing initiatives that we see, if we only would look at the Grabs and at the Ubers in the world, Lyft in the US, if we looked at the initiatives that we see with car sharing, you can imagine that this will have a huge impact on the automotive industry, because in the end, less and less people will own vehicles in the future, and the utilization of vehicles will get much higher. So it's completely change of what we see today, where the automotive market is focused on an asset that you have parked on your driveway and that you will only use 1% of its time. That will absolutely increase a lot, and where you will see utilization going up to 70%, 80% of these vehicles. So huge change in this market. Now, another change we see is on the energy side, in the electrical segment, I should say. So again, on this mobility side, that's Thomas Ford. But Mr. Edison is on the other side. That's on the electrical side. So what do we see in this energy industry happening today? We see digitization. Everything is getting digital these days. whether it is the switch in your house or whether it's a big transformer in the industry, all the electrical equipment is being digitized and being remotely accessible and controllable. Yeah. We see decentralization of energy generation. We see smaller energy generation, smaller power plants being built and constructed and being active on many locations. We see local initiatives of power generation, solar energy, wind energy. So energy generation being decentralized. And then we see decarbonization as well, or more green energy coming into place. I already mentioned wind, I mentioned solar. So the three Ds that are impacting the energy industry today are the digitization, the decentralization, and the decarbonization. Now, what I want to do in the next 5 to 10 minutes is to show you how these trends in the automotive industry and these trends in the energy segment or in the electrical segment are coming together. And that is best done by showing you a little bit on the evolution that we've gone through when it comes down to the evolution of EV charging. And of maybe I should say DC fast charging, because that is consuming so much power and having so much can have so much impact. Not in the early days. That's what you see here. We had the first Nissan Leaf coming to the market 10 years ago, and we had the BMW i3 and the Volkswagen e-Golf coming to the market. And every now and then, one of these vehicles was meeting a charger that was installed in the public domain. So not as a destination charger, but as a range extender installed along the main corridors, let's say in Europe. Yeah, and then the number of cars were growing, and already at that moment we could see and we could start to predict that while the number of cars are growing, we also saw the number of chargers growing, and we also saw the number of chargers on the site growing, sometimes even becoming so big that the total consumed energy on the location could even go beyond what was available on that location, that the grid connection couldn't fulfill the demand for the energy that was required to charge these vehicles. Yeah? So that is actually a challenge that was happening. Now, in addition to that, I've drawn cars in this picture, but I could also draw a bus in there, or I could draw a truck in there. So we now see a mix happening. We see electrification of buses, where we see big bus depots. We see major car charging sites coming up. In Europe, we have now sites coming up of 2.5 megawatt and more, with installed capacity of chargers. And of course, we have the distribution centers of many industries that now are going to electrify their truck fleet as well. So you can imagine that there's a challenge on these locations to maintain the critical mission of charging, because in the end it is important that these vehicles. I need to kill this one. Sorry for this. So it is important that these vehicles will be charged within the time frame that the driver, whether that's a private person or a driver of a bus or a truck driver, that the car is being charged in the time that they expect it to be charged. Now, to manage that, you could simply derate the chargers and derate the chargers so that they do meet the grid connection on those locations. But that's of course not what you want. So what we have to do these days, we have to put the technology in place. Small hiccup on my. Yep. We have to put the technology in place to connect all these chargers and put a controller to it. The controller then can manage the energy consumption from the various chargers and can distribute the energy amongst these chargers, and avoiding that the fuse will be blown or in other words, that these chargers do not go beyond the grid capacity on the location. So you can easily do that with derating the chargers. That would be a very simple way of doing it. But you can also do that in a smarter way, where you put the controller on site and then put some logic in there so that you can distribute the available energy amongst the chargers on the site. Next step, then what you could do is to prevent the lack of energy on the location. You could add battery energy storage to a location. And of course, if you do that, you can use that battery for peak shaving. And the peak shaving can then or the battery can then be linked to the controller as well, so you can manage the available capacity in the substation or the grid connection in the substation. You can include the power that's available in the battery on the location, and then you can of course manage and distribute the energy over the chargers. Now, in addition to simply, it's already quite a big step forward, but in addition to the battery energy storage, you can have other producers and consumers on the location. Um, and you could have solar panels, or you could have a wind turbine on the location. And of course, you could have a building as well that is consuming energy. What you actually see on this picture is a bus depot that is having a building, an office building, or and the depot itself in which the buses are parked overnight, that has a solar on its solar panels on its roof, and that has battery energy storage on its location. Now you can imagine that all the consumption of energy and all the generation of energy needs to be managed in a smart way. So this is actually what we do today with these smart controllers on the location. Now you could even go one step beyond this and bring this to the level where you now start to pull in smart, intelligent information that is available on other locations. You may want to link this location, this charging site, you may want to link this to any weather forecasts so that you can predict how much energy will be generated by your solar panels or by your wind turbine. You could link it to any fleet scheduling program or fleet management program that you have for your buses or for your minivans or for your trucks. You could even consider vehicle to grid and then look at what is the best moment and when is the best moment to start feeding back energy to the grid rather than to charge the vehicles. And then in the end, you will have a complete cost optimization and an ideal operational environment for your complete site. So charging these days and charging solutions do not stop with installing a charger on the location. Yes, maybe today in Africa, with the limited number of vehicles on the road, electric vehicles on the road today, a single charger or two chargers and connecting that to the grid, no
Yeah.
problem at all. But what you see here on this screen is where we are combining multiple charges on the locations, battery energy storage, other producers and consumers, which are really giving you the challenge that needs to be managed. Now, by controlling that on site and by giving the site remote access, you can control that in the optimal way.
It's very interesting to see that all of these elements coming together can create a full end-to-end solution where there's a lot of elements that I didn't even think of. I didn't think that you'd need to optimize charging areas because maybe it has a higher density of people that would go to it. It's little things like that that you'd never really think of, and you guys at ABB have. And it's interesting to see how we could potentially roll it out in the African context. Wim, I have a question here from Willem. He asks, will Europe focus on cord charging or will induction and battery swap also become mainstream?
Core charging will be the focus, absolutely. Induction for destination charging maybe because it's convenient. it is convenient to park your car on your driveway if you do have a driveway, of course, and you don't need to plug it in. On the other hand, we are also now looking at robotized connections. So what's the difference then between parking your car over an induction charger or have a robot to connect the connector to the vehicle? But the main
Mhm.
focus will be on charging with the cable. Absolutely.
Cable,
And
yeah.
I forgot the other option that
The other one was
Mr. William was asking.
swapping off batteries.
Swapping of batteries will not happen with cars. I just saw the short presentation on the two wheelers. Absolutely
Yep.
good business case. I go around in Asia a lot, and especially in Taiwan, it's a big success. It will not happen with cars because the IP of the
Or-
OEMs sits in the batteries, and
mm.
it is not compatible with each other, and probably they want to keep that as a unique selling point for their vehicles as well. I don't see that happening, and there's been initiatives in the past and they failed. So I don't see battery swapping to be use case
We've got
for
another
passenger cars.
We've got another quick question here from Hiten. He says, what approach and standards is ABB taking for interoperable consumer experiences on EV charging, supporting roaming services, payment systems, authorization?
If this is on authorization and payment management and the standards according to that, we use the standard protocol that exists to communicate information from the charger to a customer's backend, which is called OCPP, Open Charge Point Protocol. And that is what we use to identify yourself with the charger, and then that will be fed into the back office of the operator of the charge point, and they can then authorize the user to start charging and can manage the billing towards that customer. So that's one option that exists. Of course, there's the option of payment terminals. To be installed with the charger. And then, last but not least, there's also a technology available these days that will allow the charger to recognize the vehicle that is charging, so that at the moment that you plug in your connector, the vehicle will be recognized, the user will be recognized, and authorization and billing can all be managed in one.
All right. Well, Vim, thank you so much for your time. We really do appreciate it. And good luck in your man cage.
Thank you very much, and thank you very much for having me there.